let's start. Let's welcome you to this biggest EX mistake webinar. We'll talk about those. And before we do so, good afternoon, good morning, wherever you guys are. There is a way for you to be able to talk to us, which is through the question and answer box. At the end, we will try to answer those. We have collected some question and answer throughout the registration process. We have prepared answers to those as well. Before we start, let me introduce Bob. For my, never sure whether there are new guys or not. So Bob is our guest speaker for today, and he has over 30 years of experience in the EX world. He's a CompEX instructor as well as an instructor of the ICEX CompPC scheme. In fact, we are running this year, we will run some training program with him. They will be scheduled. You can log in our website on the training and you will see them, and you can register, sign up, pay for it, and be trained, which is the best way for you to avoid mistakes, to know what to do. He's also an inspector, a member of the USUL STP committee. So it means that he has, more experience than is needed to run this webinar. in fact, we've done several webinars together, and never he was put on the spot. He always had the right answer. So Bob, thank you for being with us. Let's go to the next slide. For a few moments, I need to talk to you about GMI, who is bringing you this webinar. So, just a few seconds. So who is GMI? GMI International designs, engineers, and manufactures a complete range of IS, intrinsically safe, and SIL certified devices for automation packages such as DCS or fire and gas, up to SCADA, and so on. In most industrial sectors, such as oil and gas to food and beverage. We have over 40 years of experience. We were founded in 1993, and we are very proud of manufacturing our product 100% in our facility near Milan, Italy. On the other end, we are global players, as you will see later. Next slide. We have, of course, we make safety products, so we take special care in manufacturing them. We care about the environment we're in, the people we work with, and the people use our products. So we use state-of-the-art technology. We have 100% traceability. We are compliant to whatever things you want to throw at us. Today, the rules are keep changing. Now we have skip new rules. We are, of course, we have functional safety management certified up to SIL 3. And we do full testing. And we have 5 years warranty on our product. Next, Bob. These are the product we manufacture. IS barriers, safety relays with and without line monitoring. We have isolators, also SIL certified, power supplies, SIL and EX certified as well. A line of multiplexers for temperature, digital, HART multiplexers, termination panels to interface with the most common system out there, a surge protection device, a liner loop indicators, and of course, functional. And today also cybersecurity and EX training and service division, as I mentioned earlier. We are present around the globe through our direct offices, many distributors. We are about 200 dedicated employees. We run many courses and we have thousands of installations. Some of our customers are listed here from the system vendor. I would say everyone from ABB to Yokogawa. We have many EPC projects we've done with EPCs. And we're very proud to supply to OEMs, which install our product in their machine, drilling rig, wellhead packages, and so on, which are run typically in very harsh conditions. Because we offer up to 70 degrees temperature range, we have a 20 years lifetime expectation, and so on. And many end users, we are on the AVL of many end users. I believe this is the end of the GMI bit. Next slide should be, let's see, yes, okay. So now it's time for Bob. And as I said earlier, there's a question and answer box below here, somewhere you can see. You can type your questions. We will try to answer them most likely at the end of the webinar, maybe through the webinar, we'll see how it goes. But now it's for Bob to take the helm and guide us through this webinar.
Okay. Well, thank you, Paulo, and thank you all for participating. This is, I was trying to figure out how many webinars we've done. We've done, I think, maybe 12 to 13 or so over the last 12 months with all this COVID stuff, and the responses have been great. And this is, I think, the second time we're doing this one. And the last one, we had a ton of questions, so we ran a little bit long. So I'll try to shrink it down to keep you guys here for no more than an hour. So,
Bob, just yesterday we had a sales meeting and I looked at the webinar records. We had over 1,000 different, so new people in the webinar last year.
that's fantastic.
It's a lot.
That's a lot. That's awesome.
We had over a couple of thousand, but people are repeating, but new, individual, 1,000. Okay, go ahead, sorry.
No worries.
I might disappear here, look at the question and answer.
So one of the things when we talk about EX mistakes, and this is my interpretation. Please understand, this isn't necessarily some there's a clearinghouse out there that can tell you what all the major mistakes are. We teach various mistakes. I say we teach how to remedy and how to rectify a lot of the mistakes and how to find these issues. But when we really boil it down and look at the root causes of a lot of mistakes that we see, it boils down to different roles and responsibilities. And it's not always just operational people. That's one of the things that I think there's a perception out there that people think that a lot of these industrial mistakes and these big industrial accidents that we hear about, that it's really the operations or the field guys that are making mistakes and doing all that. And there's certainly some of that, and there is truth to that. But when we really look down at the numbers and we start looking at the root causes, we start finding out that in many cases, some of these industrial accidents actually come from the very early stages. Things like specifications not being correct. There could be things, as you see on this pie chart, the changes after commissioning. We might do design, but then all of a sudden it gets changed. Certainly the operations and maintenance, but there's a lot in there as well as design and implementation. So the mistakes that happen that cause these root accidents are actually all throughout the whole process, if you will. So I don't want to emphasize one thing versus another because really the mistakes can come from multiple different sources. And as we go through these, you'll see that some of these are certainly more from the installation side, some of it's from the design side. So we need to be aware of that. So how do we define mistakes, or where do we find the definitions of what kind of errors that we're going to see with regards to electrical safety in hazardous locations? The main standard, if you really want to focus your attention on, is really the -17, the 60079-17. I know a lot of people on here are probably manufacturers or maybe users. If you're a manufacturer, you're going to follow some of the general standards, maybe like -0 and -1 and -11 and some of those. Well, the -17 one is one that gets overlooked by manufacturers because this deals with the inspection and maintenance, if you will, of EX equipment once it gets installed. I always recommend to skid package builders and manufacturers to take a look at that because within the -17 standards, there's actually some really good EX checklists, if you will, to make sure that when you're doing your FATs, when you're doing your final inspections, before you ship it out to the customer, that you've done all your due diligence. And so we're going to see some of those types of issues. In the United States, we've adopted the -17 as a UL standard. The other standard to keep aware of is the -14 standard, and that's your design and specification guidelines. So we want to follow -14 from the design standpoint, but 17 is the standard that we use for inspections. So here's an example of what you would actually find in the -17, right? This is a sample inspection sheet, if you will, that when I go out to a site and I'm doing my EX inspections, and we're going to use these types of charts. And again, it's very handy. It's good for everybody to understand. The way we want to read it is that if we look at that first line, Is the equipment appropriate to the EPL zone requirements of this location? We have grades of inspection, either detailed, close, or visual inspections, and we carry those out for different protection concepts. So again, this is just one part of one page. There's quite a few different check sheets within the Dash 17. Very, very helpful to be able to use. So again, does it only the EX inspectors that need to know this information? No, it really should be everybody within the supply chain, that we catch these mistakes before they actually leave a factory or once they're installed. So one of the biggest mistakes that we see is the equipment is not suitable for the environment. Now, suitable for the environment could be a number of different factors. It could be based upon the gas group. It could be based upon the temperature code. It could be the EPL or zone of suitability. You know, these are all examples that are pretty common, right? And we understand this. One thing that comes up, ambient temperature. The default for all EX equipment is -20 to +40. But I know in many parts of the world, +40 is not that terribly hot. We get above +40 in the Gulf of Mexico, offshore markets quite a bit during the summertime. And certainly in the Middle East, it's not unusual to see +50 or +60. So we have to be aware of that. Remember, EX equipment, unless it's marked, it will always be for -20 to +40. IP ratings, certainly the certification. You know, a lot of times we see products that might be certified under one scheme, but yet the project requirement requires a different scheme. So we have to be aware of that. And certainly the environmental conditions. Where are we going to be placing this equipment? So if we look at this label as an example, right? The requirement under the project is Zone 1, 2C, T6, +50, IP65, and we require IEC EX certification. So by looking at that label, we can basically see, and let's see if this actually comes up. We see a couple things here. We see that our ambient, our upper end is only rated at +40. However, the project requirement is +50. And if we look at this actually very closely, we don't see the ATEX cert, but the markings with the EX hexagon and the CE mark is actually telling us that that is ATEX. So this may or may not have IEC EX certification, so we have to maybe do some further investigation before we start using it. So looking at another nameplate, if you will. The requirement again, Zone 1, 2C, T6, +50, IP65, we need IEC EX certification. So what do we see with this particular one? We see, again, in this case, it's ATEX only. There are some things on here that were okay as far as potential ambience. We see actually some T codes on there. And without going into all the details on how to read the label, but we see that we have a +80 and we get a T5. And we get a +70 rating at a T6T rating. So we do meet the +50 degrees C, but we don't see any IEC EX certificate or labeling, and that's one issue. So again, these are things that we usually would catch at the very, very early stage, right? And hopefully this doesn't get installed and then gets sent out to a particular location or installed in a facility, and then an inspector comes along and says, hey, this doesn't have your IEC EX cert. We have to remove it. We have to address it. We have to do something. Now here's another one. Again, similar application. In this case, we actually have quite a few issues. In this case, EXNA and NC is the protection concept. And based upon the EPL of GC, this is telling us that this product is only suitable for a Zone 2 environment. The requirement for the project is Zone 1. The other thing we see here is that when we look at their certificate, we see a U at the end of it. We're going to talk about this here in just a little bit, but when we see a U at the end of a certificate, that means it's a component. And that means that we cannot install a component into a hazardous area without further assessment. So typically component certified products are usually things like switches, or some other device that's actually going to be installed as part of an overall system. Another giveaway is that usually component certified products will not have a T code. So if we don't see a T code and we see a U, that should immediately be a red flag and tell us that, hey, this product is a component. This cannot be installed. We have to be wary of that. In this particular instance, I think, if I'm not mistaken, the requirement is T6, but we only have a T5. And the other thing I think in this particular instance is that, oops, going back, we also only have a 2B plus H2 where the requirement is actually 2C. Now, this particular product does have an IEC EX cert, and we see that by looking at this little information right here. And it also has your ATEX certificate right here. And just talking about labels, this is the marking string that you would have a requirement under IEC EX, and this is the marking string that you would find under the ATEX directive. All right, so let me close that and continue on. So I'm not going to bore you to tears with all of these, but you get the idea, is that we need to look at these labels, we need to understand these labels, and we need to understand the data sheets that the manufacturers are providing before we select these products and make sure at the very early stage that they're suitable for the project requirements. Again, another example, in this case, ATEX only suitable for Zone 2 applications. Lots of issues here. This one was also another one, ATEX only. So I'm beating you I'm beating you over the head with this. So Paulo, we have our first.
Oh, here we are. Well, so I will launch a poll. So make sure you guys are still with us, not asleep. And the question is, what is the IEC standard that provides guidance for inspection of EX equipment and installation? Several are listed, but basically -1, -14, -10.1, or -17. While you do that, Baba was thinking, there is so many issues with the labeling and reading the marking that we have had a webinar on the
understanding the marking.
You remember? Maybe we should bring that standard, make a complete teaching. Make a webinar on how to read this label, because as a matter of fact, they are complex.
I think we've done that, Paulo, actually.
We had one on the we had one on the EX poster where we show how to do that, right?
Right. But yes, we spend a little bit more time on that.
We revive that one day, because it's not easy. Okay, so guys, most of you have answered. Let me end the poll. There's no judging here. We don't know who's voting what. We just want to make sure you're understanding what Bob is talking about. And polling, show the result. So, Bob?
Yeah. So actually, we see a typo because the correct answer is actually 60079-17. There is not such an animal as 10-17.
Oh, that is a typo. You're right. I didn't see that in the poll. I saw it, but anyhow, you guys got that, right?
So that is the correct answer. Just as an FYI, 14 is the design standard. So, I mean, we find obviously we need to follow 14, but 17 is really our inspection standard. The -1 is the standard that applies to the design of flame-proof equipment, and 10-1 is the standard that deals with area classification. So those two standards are important to understand, but really the correct answer would be D, the -17.
Great.
So continuing on. So mistake number 2, So modifications to EX equipment outside of what is allowed. So one of the biggest things that we see is additional entries drilled into EXD enclosures, adding additional components inside the enclosures outside of what is allowed by the certification, and things like addition of items such as O-rings, Teflon tape, labels potentially to existing EX equipment. Now, I put labels down there because sometimes we need to label our equipment, right? But we have to be careful as far as how we affix labels to EX equipment. We want to be very careful when we're doing things like affixing them with bolts or rivets or drilling and doing anything like that. The moment we start doing that, potentially we may be violating the requirements that the manufacturer has set forth. So be aware of that. We need to make sure that any types of labels that we put on EX equipment, that's okay and allowed as per the manufacturer's recommendations. So here's a couple different examples of just general mistakes, right? The one on the left, there's actually a requirement for EXE enclosures. Obviously, it's a mess, but there is a requirement, the maximum length of cable that you can run on the inside of an EXE box. We can't do typical these service loops running all over the place because we want to make sure that we minimize the amount of heat buildup, and cables on the inside of enclosures are resistive. They're going to generate some additional heat. So we have to be very careful in our installations with regards to EXE. On the right-hand side, we actually see a gland going into an adapter, which is certainly allowed, but it looks in this particular case that we might actually have two adapters. So these are two different examples of some things, modifications potentially to existing EX equipment. Now this slide right here, we look at this and we could say, hey, this looks perfect, right? We see a lot of glands, everything looks fine. We don't see any additional entries as far as we can tell. We look at the components on the inside, we say, hey, this all looks very nice and tidy. Well, here's the thing. When we're doing an inspection, one of the things that we have to have is a copy of drawings, right? We have to have GA drawings, or at least what was produced, so we can compare versus what is actually installed versus actually what we're seeing, right? It's kind of like a road map. If you don't have a map, you don't know where you're going. So in this particular instance, at first glance, we may say this is perfect, but then all of a sudden we start looking at the drawing and there might be additional components that were put in, or maybe there was additional entries that were drilled and tapped. And even though they look fine, if it wasn't done by either the manufacturer or a service center, those could be potential issues based upon the fact that it may be too close and we could potentially rupture the enclosure, in this case, an EXD box. So even if everything looks fine, we still want to check it out and compare it versus what should have been produced. In this particular instance, and I can't remember exactly what the mistake was. Let's see. We have a couple different things here. Actually, this is an interesting. Okay, now this clicks my mind. It's been a while. It's early in the morning. I apologize.
It's too early for you, so
Yeah. So there's a difference between these labels, right? This is two different manufacturers, and they're basically making a flame-proof box. So when we look at the top one that's got the little right here, we see EXDB, and then we see IA, and then gas group, T code, so forth and so on. Down here, we see EXD. Now, D is not bad, meaning the markings. There's actually a new requirement to put a letter at the end of the protection concept that is a fairly new development. So now things that were previously marked EXD will now be marked DB. That doesn't mean that this bottom one is not good. That's not the case. That's just the older markings. However, notice this. We have also IA. What this means is that with this particular enclosure on the top, it's actually a flame-proof enclosure that contains intrinsically safe associated apparatus. On the one below, I don't see an IA. So when I open up that box below and I look inside and I see intrinsically safe associated apparatus providing protection downstream to some devices, I don't see an IA. Guess what? That box is not certified to house intrinsically safe components, as is. So we need to be aware of these little things to make sure that we're we're aware of all that good stuff. So a couple other things that we see that are pretty common. The box on the right-hand side. This is one that these are a couple that I've done where we see a combination of maybe certified stopping plugs, and then we see things like maybe either traveling plugs or in this case, non-certified plugs. So we have to make sure that the components that we're putting on the outside of our EX equipment matches the protection concept of the equipment itself. And on the left-hand side, excuse me, that's where we see some Teflon tape. We do not want to put Teflon on any threaded entries, even though it's a great idea for plumbing fittings and water fittings. The fittings that we see here or cable glands, that's actually a flame path. And we don't want to impede the flame path, that metal to metal surface, by the use of Teflon tape. Thread lubricant is okay. Things like Teflon tape is not okay. Excuse me. So the third mistake, improper selection and installation of cable glands and accessories. And again, this is there. Some of the pictures kind of jump all over the place, but again, things like non-certified glands, improper installation of glands, not using the appropriate accessories, using EXE accessories and EXD enclosures and equipment that can be an issue, failing to take note of special conditions for safe use, using stopping plugs within reducer fittings, very, very common. That is not allowed. And then using multiple reducer fittings. So these are some of the things that we find that are very common, and that we'll know these things by looking at our inspection charts within dash 17, and we'll find this information all in dash 14. So we start looking closer, we start looking at the inside of cable glands. We do detailed inspections, we see that glands are not installed properly. Maybe the retaining ring is not properly secured. In this case, what we're seeing here, this is not necessarily a fault, but what we're actually seeing here is compression around the inner bedding, which is causing cold flow, which could damage the cable. So we need to be aware of those types of issues, right? What we see over here is that we see something like a traveling plug. Excuse me, I got a bug in my throat here. So what we see over here is a traveling plug. That's a non-certified plug. Traveling plugs are usually put in by a manufacturer just to protect the threads during the transition from shipping from the factory to the field. So we always look for traveling plugs. We see these commonly when we're going out and doing field inspections. Make sure that they get replaced with a certified plug. Okay, we'll go to the next one. There we go. Now here's a couple that may or may not be very obvious to you. And let's see if I have these circled. I think I do. So what you see on the left-hand side, we have quite a few fittings. We have a cable gland, we have a reducer, we have a 90-degree fitting and an additional reducer. So the standards allow us to do certain things, but that may be a little bit extreme. We have too many adapters, reducers. We would have to shrink that down to basically be able to use that type of scenario. So be aware of that. The picture on the right-hand side, that may be an issue, because we see that those are nylon cable glands, and typically that's going into an EXE type enclosure if they're certified. However, that box, just by looking at it, is actually a flame-proof enclosure. That doesn't mean that the nylon glands are not necessarily acceptable, because if that transmitter is being protected by the use of IS, we might be able to use nylon glands. Generally speaking, however, because it's going to be flame-proof, we would want to use a flame-proof gland. So that issue right there is also a problem. So we have to be aware of that. These are just pictures of some other installations. What we see in the United States a lot is people using seal fittings, and I know in the international community we call them stopper boxes. We typically call them seal fittings. So we spend all this money on a very, very, very expensive, large explosion-proof or flame-proof box with all these nice bolts, but then we don't seal them properly. Um, we've basically defeated the whole purpose of having that enclosure in the first place. And obviously on the right-hand side, we see some installation with cable glands where we are not properly sealed. Again, some other pictures here. Again, some of this is more from an installation standpoint. What we see over on the left-hand side is that we have some people that have used, actually, it looks as if two different compounds, a liquid compound and a putty compound to seal up, to make explosion-proof or flame-proof seals going into a flame-proof enclosure. Those are definitely not certified. On the right-hand side, it's a little bit difficult to tell there, but what we actually see is an IP washer, and an IP washer is appropriate for use in connection to provide an ingress protection seal going into an enclosure. However, if we look very, very closely, we see that that IP washer actually looks a little bit too big for this application and is not providing any protection whatsoever. So some of these little things are things that, again, you wonder what an inspector is doing. This is the stuff that we're looking for, right? We want to make sure we check this stuff out. And that's why we are usually not well received by clients when we come in and we start checking all this stuff. So again, if we do this and we address it before it gets into the field, then a lot of these problems get alleviated. Similar type situations, right? A question usually comes up on on cable glands when we're doing inspections. We, as an inspector, there is, again, visual, close, and detailed inspections. One of the important things to note is that we never do open up cable glands during visual or close inspections. We can touch them, we can look at them, but we don't open them up. We don't want to open up a cable gland unless the equipment has been de-energized, and in many cases we have a gas-free permit. But what we're seeing here on the first, the slides over on the left-hand side is obviously damage to the cable. And then on the right-hand side, when we start pulling off the shrouds and looking at the cable glands, we see that the armor has not been landed on the inside of the ring. So it's common practice for inspectors when we do inspections on cable glands, we're not necessarily going to open up every single cable gland in a facility or on a skid, but we're going to do a sample representation. Now, I promise you the picture on the right-hand side, those three glands all were improperly installed. If I was doing that inspection, I would assume that all of the glands that are installed underneath those shrouds are probably not properly installed. And I would say, hey, we need to redo those. That brings up another point. What you see on that picture on the right-hand side, you see some cable glands, and then behind there, those are actually cable shrouds. I strongly recommend against the use of cable shrouds because, number one, in many cases, they just hold the moisture inside against the gland. They cause a lot of problems. But secondly, if we're doing an inspection, we have to slide those shrouds down or cut them off. And at that point, then, okay, we've removed them. So I know many customers are getting away from the use of shrouds. I would highly recommend you don't use them as long as you're using a high quality gland that maintains a very good high IP rating. So that's my own 2 cents. Oop. Go to this slide. Again, you see a lot of issues with cable glands. On the left-hand side, what we've got, we have IP washers, and it looks like everything looks fine there. We have earth tags. Everything looks okay there. We obviously have a situation with our cable being pulled out of the back of the armor. We need to be aware of that. On the left-hand side, one of the requirements is that generally speaking, with certain glands, we have to remove the plastic tape around the internal bedding. On the left-hand side, it shows that that tape around the bedding hasn't been removed, so that's an issue. And then what we see on the right-hand side, we see packing of the glands after the fact by taking some compound. So again, I'm highlighting a lot of things with cable glands that have to do with installations. But again, we want to be aware because these faults can occur at all different kinds of areas. These are just two examples of glands that, again, are not properly installed. On the left-hand side, that's a barrier gland going into a flame-proof box that wasn't properly poured or packed, if you will. On the right-hand side, that happens to be an example of a diaphragm seal that was torn, that, again, the installer should have caught that before it was installed, and check it out. Make sure that those issues are not there. So here's an example, actually, to kind of throw it out to everybody here, and I know you really can't answer it, but is this a mistake? We have, in this case, we have two different cable glands, same manufacturer, going into a flame-proof enclosure, and the gland on the right-hand side is a barrier gland, meaning it has a compound material. The gland on the left-hand side is not. Would that necessarily be a mistake? Actually, as per the latest IEC 60079-14 standard, that may not be a mistake, because the requirement of selection of a barrier versus non-barrier EXD gland is based upon cable length. So, just as a rule of thumb, if we have very short lengths of cable going into flame-proof boxes, 3 meters or less, it would require a barrier gland. If the cable is 3 meters or longer, it does not necessarily require a barrier gland. So think of it this way. The cables on the left-hand side, if those leads are going off, say 20, 30 feet, that gland is perfectly acceptable. The gland on the right, if it's going into a device that may be located 5 feet away, that would be the appropriate gland. If you are not aware of those types of things and you just come in and take a look and you say, hey, wait a minute, different glands going into the same enclosure, that's why it's really important to understand the requirements in the -14 standard to make sure that you're up to date with all the latest rules and regulations.
Okay, Bob.
Here's another poll question, Paulo.
Okay, great. Well, can you guys use an EX certified stopping plug in conjunction with the EX certified reducer fitting on an EXD enclosure? Yes or no? But there's a 50-50 chance here, you can make it. Well, I was again thinking through our classes, which we're gonna run on the two modules that I forgot is two.
Yeah.
Will we teach some of this stuff or not?
Yes.
Okay, good.
Yeah.
Because it's there's so many type of glands, so many ways you can install it, and honestly, when I looked at it, I said, guys, an IS barrier is a better solution. Forget the glands, you cannot make a mistake.
Well, but here's the thing, Paulo, you still have to have glands going into devices.
A motor. Yeah, I understand, but
you're right.
It's that's why I so much strongly believe that IS is a safer solution than EXD, because it's less likely you make such mistakes. Okay, well, most of you have answered. Let me end the poll. We are about 50-50. So, Bob, it's not clear. It was not clear to me either. If I remember from last time, was no, but I'm not sure.
The correct answer is no. So, what we can use, right? We can use a certified reducer with a gland, meaning that say if we have an entry that is M25, we have a gland that's M20, we want to reduce it down so we can use that gland. That's fine. We can use an M25 to M20 reducer, put a cable gland in it. That's okay. However, if we come back to that same entry and we have an M25 hole and we have an M20 plug and we say we want to use that M25 to M20 reducer, that's not allowed for EXD equipment. We talk about this a lot in the courses and stuff, and people ask the question, why? What's the issue is? And I can understand why people would think, okay, I'm using a certified plug, a certified reducer, and I'm putting it in a flame-proof box. We're still maintaining flame paths. but we're introducing an additional flame path in effect. So the requirement, actually, the standard is very clear about this. It states we cannot use a reducer with a stopping plug. We can use a reducer with a gland, but we cannot reduce and then use a gland. We just need to use a single reducer, a single gland, or a certified stopping plug.
Makes sense, because the flame path is, part of your safety.
Absolutely, absolutely. So another mistake, and here's intrinsic safety, right? So there is problems on IS. Some of the biggest issues, and we've talked about, we had a webinar on just some of the big mistakes on IS particular.
Right, you can make
But
mistakes.
certainly no segregation between intrinsically safe and non-intrinsically safe circuits. No labels indicating IS circuits. Improper grounding of intrinsically safe. No descriptive system documentation. I was talking with a customer last week and I asked him specifically, do you have your DSD? And he looked at me like I was off Mars or something like that. And I said, no, it's your descriptive system document, which basically what your DSD is your drawing that shows your associated apparatus, your intrinsically safe device, your end device, any interconnects between the two, such as a junction box, and your cabling. It should have all that information available. And that's a requirement under the -14 standard, as well as the -25 standard for IS systems, that every loop should have a descriptive system document. Failure to select certified equipment where required, i.e. non-simple devices, and then modifications to the design after the installation, such as maybe increasing the cable length, substitution of a different barrier, those types of things. So looking at these two pictures here, what we see on the left-hand side is we have IS and non-IS within the same enclosure, which is fine. We can do that. We maintain a separation of 50 mil segregation between IS and non-IS. And what we've done with regards to the positioning of the glands, right? This is a 50 mil separation. This is power over here. This is IS over here. But then we've kind of screwed this whole thing up by running our IS and non-IS against each other. So we cannot do that. The same thing holds true when we look at this particular installation, right? We have our protection from our IS going out. We have our incoming power. But what we have done, we have looped our power cables all the way around. So we've defeated our 50 mil separation. So we want to make sure that when we're using IS, we have segregation between IS and non-IS. Same thing here. These are two different examples of real world examples, right? We have IS over on the right-hand side in the picture over here where we have protection coming out, protection coming out. We have power over here. We have a separation, but now we've taken our IS circuits and obviously we do not meet this 50 mil separation between the power and the IS. So this is, you can barely see this, but that's actually a barrier gland that's sealed. So the solution here to remove that is not an easy one to take advantage of, right? Same thing when we look over on our left-hand side, we have our incoming power going to the barrier, we have our outgoing, but what have we done? We've brought them basically together at this particular point in time. So be aware, when we're doing intrinsic safety, we need to make sure that we keep this separation of IS and non-IS. Mistake number 5 is actually using a used certified product. And I apologize because this label is a little bit difficult to see, but what we see at the very back of this certificate is actually a U. And that means that this manufacturer supplied an empty enclosure. The client, in this particular instance, installed certified terminal blocks. However, this is not a assembly certified product. So therefore, this was rejected by the client. Even though it looks fantastic, it's done properly, It's not an assembly certified product. Again, if you see this U, that's a problem. The other hint that you will see is that there is no T code. There is no T code, right? Why is there no T code? Because the manufacturers supplied this empty. They don't know what you're going to be putting in it. That T code could change based upon the number of terminals or the various devices that you're putting on the inside of this thing. This is one of the biggest issues that I see with so many different people that buy EX equipment, that they buy component certified products, and then they fail to understand by adding components or doing something different that this product will violate its certificate, and we cannot do that. This is an example of the same product. If we look at the label here of these two devices, it's actually the same part number, right? It's an SX29-1N. We see that. But if we notice on the left-hand side, we see that it has a use certificate. On the right-hand side, it does not. So the one on the right-hand side is a small little flame-proof box that has 10 terminals rated at 2.5. It's a fully certified enclosure, and it has a T code. The one on the left-hand side is the exact same enclosure, but it was supplied without any terminals on the inside. So it's a component certified product, not an assembly certified product. Mistake number 6 is conditions for safe use on EX equipment. We won't go through all of this, but any piece of EX equipment that comes out there that has an X condition means that there is some sort of condition for this particular piece of equipment to be safely used. This is also a mistake because some people, they buy it, it's certified, it's assembly certified, but they pay no attention to the X condition. So we have to read the information in the X condition, which is in the certificate that gives us the information in which to safely use this equipment. So be aware of that. Any product that has an X condition will have some sort of specific conditions for use. Make sure that whatever it is that we're doing it. Mistake number 7, improper wiring techniques, not tightening up on unused terminal blocks, too much copper showing inside of EXE equipment, undersized earthing conductor, using cables with a non-barrier EXD gland for installation into EXD enclosures that are not circular, etc., etc. So we have to be aware of these types of things. And again, as Paulo mentioned, this is all the stuff that we teach in the various courses that we offer. So, but this information is, again, much of this information is in 60079-14. So just some other examples of installations that, again, improper wiring. And then I think this is the last one, lack of proper maintenance on EX equipment, right? On the left-hand side, somebody has gotten rid of the bolts. They use some baling wire, so to speak, to keep the enclosure closed. Excuse me. So that is certainly not a safe installation. On the right-hand side, we see some corrosion on the flanges on a flame-proof box. We need to be very cognizant of that fact because the flanges of a flame-proof box are actually a flame path. So when we start having damage to those flame paths, that means that potentially we have a very dangerous situation. So we need to maintain our equipment. On our left-hand side, obviously, we've had some water ingress into an enclosure, a settling of water. And on the right-hand side, we see certainly dust that is accumulated. And of course, the cable glands are not properly installed as well. Actually, I do have one more. Earthing of intrinsically safe Zener barriers. We need to make sure that IS barriers are, if we're using Zener barriers, we need to make sure that we're using a clean earth. And clean earth needs to be separate from our normal dirty earth, right? And so this is one of the biggest issues that we see, that people will take Zener barriers and they'll fail to earth them to a dedicated IS earth. So that earth actually needs to have less than 1 ohm resistance, and it should be as short as possible to the actual physical ground.
Okay,
I
Bob, we
think
have
this is our
our
final
last poll
question.
today. Maybe I suggest you, if you want to step out, get a glass of water or something. You seem a little, no
Yeah.
issue. Just go ahead and do it. This is a simple question, guys. I mean, a simple answer we talked about throughout the entire, several times in the webinars. What letter at the end of the certificate for ATEX or ICX signifies a component certificate? X, B, U, or Y? I know the answer to this one because we have some component certification for some of our product, and they carry one of those letters. And I spoke a little earlier, and I said, EXT safer than IS. It is safe when you do things the right way. So that is why it's important to be competent and to understand how to do things correctly. As you very clearly mentioned, an IS barrier where you bring the cable together defeats the purpose of the barrier. Or a cable gland that is not installed properly, or a box, an EXT box where the bolt had been removed and some fishing wire, all that together, of course.
Right.
But you imagine, how can people do this? I don't know.
Yeah, Paulo, it's not that people do this stuff deliberately. Nobody ever wakes up and says, I'm gonna make this thing dangerous. It's just a lack of knowledge. It's a lack of education.
That's what I mean. They're not competent. So that's why it's so important to be trained, and to come to our courses and courses in general, so that you know how to do things correctly. Because any of those mistakes you have come across, it's a ticking bomb.
It is. It is.
Okay, let me end the poll here. Share the result. I would say, what is that? 70% of you answer correctly. X identifies a different sort. We talked about X, but it was in a different content.
That's right. Yeah. So every cert will have either an X, a U, or no label, or no letter. Excuse me. So they'll again, an X means a special condition for safe use. A U means it's a component certificate. If it doesn't have any letter at the end, it's just assumed we can install it as accordance to the manufacturer's documentation and the standards. So
Bob, we are running late. Let's sum it up. Otherwise, we don't get a chance to get question and answer.
Right. So again, you saw a lot of errors. Many of this was in the installation and maintenance, but a lot of this does take place at the very early stages. So wherever you are in this whole supply chain, as a distributor, as a manufacturer, as a user, as a skid builder, a contractor, whatever, it's important for all of us to understand the EX issues so we can catch those before they become dangerous, right? That's the important thing to remember. So it's really up to you. Get more educated, take responsibility for catching those errors.
Okay, great. Well, here is our contact details. Later you can see, we will share this information with you guys. I don't see any question and answer here, but I will, we have prepared some. So let me share the presentation, Bob.
Okay, you want to share?
Oh, you got one, so you want to go ahead with that? That's fine. You can share that. So you guys, as I said, you are allowed to ask any question you want on that box, the Q&A box. If you do have any question. In the meantime, we received some question through the registration process, which we'll answer to right now. So go ahead, Bob.
Yeah, Paulo, can you see my screen?
Yeah, industrial accident leading to regulations.
Yeah. So usually what happens is, as we all know, is that major industrial accidents change the legislation, right? So probably the biggest ones that we really have seen in the offshore market was obviously the Piper Alpha and Deepwater Horizon. They led to a revision and tightening up on regulations offshore. The Buncefield and Bhopal disasters that really did change some of the regulations in various parts of the world. So unfortunately, it's usually major industrial accidents. They do lead to stricter regulations, and the standards do change based upon both technology and what the market actually is looking for as well. This was, yeah, this was
EN 50495 standard, right?
yeah. This actually, I think, was a question from, we didn't have it from this group, but we'll basically talk about it just briefly. This is a European standard with regards to safe functioning of explosion safety devices, if you will. So a good example is a motor starter providing protection to an EX motor in a hazardous area. So what you see over there on the right-hand side is actually a little motor contactor that is actually rated to protect an EXE motor, and it's marked appropriately for that application. So it basically has been matched, if you will, to that motor. So that's where that standard comes into play. There's certification for equipment that's going into hazardous locations, and then we also need to take into account the equipment that's controlling and monitoring the equipment that's going into those hazardous locations as well. So be aware of that.
Yeah, this question we got was about breathable apparatus criteria and what protection concepts are allowed.
Right.
Not directly pertaining to, but anyhow, it's an interesting question.
Yeah. And I think this came up actually from the last webinar, but generally, respirators, battery units are limited in protection concepts. So generally what we look at is things like intrinsic safety or non-sparking. We really encapsulation and flame-proof components, but those are the protection concepts that we would typically look at when we're designing respirators for use in hazardous locations.
Well, this is a tough one. How to use IS barrier on TCP or other serial line communication? If we have DCS and control system in different areas, I actually did prepare the answer to this. You have to, create a bridge across from the safe area to hazardous area using two devices. In this case, talking to each other, so you have the blue in the middle. Suppose perhaps you're crossing an area which is hazardous location from safe to safe, but crossing, that's a solution you would have to use.
Okay. How to properly
wire screens. That's
yeah.
a tough one.
So this is usually a question that installers get asked an awful lot. Cable screens are usually earthed at one point, normally at the non-hazardous end of the circuit. It's a requirement to avoid the possibility of the screen carrying an incentive level of circulating current. So this is where this is how we would deal with screens typically on IS circuits or instrumentation cable. We're going to land them into additional terminals, but we're going to bring those all the way back into the safe area. Sometimes we'll leave them floating in the hazardous area. When we leave them floating, one of the requirements, we don't want to use things like tape. What we would say with that screen wire, we would take sleeving, heat shrink, cold shrink tubing, put a cable tie on it or an insulated cap, and that's how we deal with our screens or drains with regards to hazardous locations. Best bet, if we have extra terminals, is go ahead and treat them as a spare core and install them into a unused terminal block.
Next question, I believe, is on maintenance of our equipment. How should we plan for it?
Right. So there are different types of inspections. There's grades of inspections. How frequently the -17 standard goes into detail, and we do teach this a lot. But basically, this is really where you want to go in and take a close look on. The -17 standard will give you a lot of that information as to how to carry out your inspections. It also talks about the competency of the personnel doing the inspections. So there's a lot of good information in there.
17 standard.
Yep.
How about using a removable gland plate in an EXD enclosure?
Yeah, EXD enclosures typically don't have removable gland plates because EXD boxes are cast enclosures, right? Typically sand cast, pressure cast. However, EXE enclosures do have gland plates, so certainly that is an option. The reason for gland plates primarily is to make it easier to install cable glands or to punch the holes in the field to install cable glands. And if you make a mistake with a gland plate in punching a hole that's either too big, too small, or not right, you can always replace the gland plate as opposed to having to replace the entire enclosure. So certainly gland plates are common, and but not for EXD.
There are some boxes out there, Bob, that I've seen. There are stainless steel EXD boxes, no?
Yeah, there is. They're cast. They're usually welded type stainless steel, big thick walls.
They do
And so,
not, you cannot put a gland plate on those.
no, no, they still have to be drilled and tapped like a sand cast aluminum type.
What about commissioning, after installation commissioning of an IS system? There is a recommended periodicity to validate the system. How often do I need to check?
Yeah, so in the 17 standard states that every piece of EX equipment shall be inspected at least once every 3 years. So 3 years is the number. There are specific installations where you would say things like portable equipment no more than a year. There's some other ones that they're spelled out. An IS system can be verified under live conditions because it is inherently safe, right? But we want to be careful if we're testing, for example, testing of IS barriers to see if they're actually working. We don't want to introduce electrical charges into an IS loop during in a hazardous area. So we want to disconnect the leads from an IS barrier. You know, there's different methods to treat IS. So we do need to be careful. Generally speaking, we want to go through our gas-free permits. We want to do our lockout, tagout. But there are some exceptions that we can do things, especially around IS.
I know we have a few more questions lined up. You guys, you want to stay with us? I see you're still with us, so go ahead. This is talking about Zener versus galvanic isolated barrier. There are quite some differences, but the biggest difference is that the galvanic isolated barrier, an isolator, does not require grounding to be safe. It does not require, and so with that comes the saving and
safety
and the differences.
Yeah, I mean, here's the important thing to remember with Zener barriers. If you don't have a dedicated earth, or if you don't earth them, right, then they're not providing you any protection. So, you know, why spend the money on a barrier if you don't use it properly? So there's more mistakes to be made with Zener barriers than there are with galvanically isolated barriers. So we certainly recommend galvanically isolated for all those applications.
There was a question about IA, IB, IC. What are these different protection concepts, advantages, how they can be used?
So IA is suitable for 0, 1, and 2. IB is suitable for 1 and 2. IC is suitable for zone 2 only. So IA, as an example, IA barriers will have 3 independent Zener diodes as part of the protection process. So it's a fault tolerance that allows these products to be used in a more onerous application. So that's why we have 3 levels of intrinsic safety.
Yeah, it is a little more than just diodes, but yes, they are more fault tolerant, more safer, if you wish. Can I install an IS barrier in hazardous location? If you take for example, there are certified for installation in deep 2, zone 2. But if you want to go in zone 1 or zone 0, on deep 1, you cannot, unless
you install them. Yeah, right. So that's where we saw that box when we talked very early on, where we saw an EXD box where it was marked EXD, and then in brackets should have IA. That means that we had a flame-proof box with associated apparatus providing protection downstream. So absolutely, you can install barriers in hazardous locations, but be aware of the limitations based upon the selection and based upon the barrier where you can and cannot install them.
Well, this question, it is possible to install, what was the question? To install a non-certified simple element like a push button using a barrier. Yes, so a simple device, right?
Right.
Yeah.
So basically, when we use barriers, anything downstream from the barrier, if it's not an energy storing device, we can certainly use general purpose equipment. So that's one of the big advantages of going with intrinsic safety. Now we don't necessarily have to have all very expensive equipment. So yes, we can use things like switches, resistors, simple semiconductor devices. Oh
Which
boy.
is the answer which is the most used ASLOC protection method? I guess it depends on many
Yeah.
things. The world you live in and the application you have.
Yeah. I mean, in generalities, high power devices, typically we're going to use more EXD. We're not going to make them EXI. If we have non-switching devices, it makes sense to go EXE if we can. A lot of control panels, we might do purging. In some cases, high voltage switching devices, transformers, we might use oil immersion. So there's a lot of different protection concepts. There's not necessarily one size fits all. There's different ways to address these hazardous locations with protection concepts.
I believe we tied the next question together because in which application we can use IS? Well, IS you can use in low voltage application. It's about limiting energy. So, we have to limit and the energy you can limit is very small. So you can drive a switch, a sensor, a solenoid valve, but, tiny solenoid valve or sounder beacon and so on. We always get these questions. We put them in our question answer all the time. What I'm interested in something else. I don't know how a SIL3 relay works. How about functional safety? How about and based on that we create our webinars. But please look online. We have our schedule. We also record this webinar as all the webinars. And I believe next slide shows our YouTube page. Yes, you can go there and review my errors in English and Grace Bob's answers. And I think that's about it. Let me do one thing. There's one last poll we want you guys to answer to. How did we do? How did Bob do? Thank you again, Bob. We are running a little late, but you're always, generous with your time. And same for you guys. You never leave us. We could stay here longer, I imagine, but it is lunchtime, and for you, it's breakfast time. So
Yes.
So we have, let me see, end the poll here so we can move forward, share the result. Most of you say excellent. Thank you, guys. Thank you, Bob. We'll see you next time.
Yeah, no, that sounds great. Thank you very much, everybody, and have a wonderful day. And be safe out there. Be safe.
Try to be safe so we can be here together once again. Now you took control, so now you have the button to shut it down.
All right. Take care, everybody. Bye-bye.
Ciao, Bob.